All right, welcome back everybody to the 13th week of the Python session. In case you are joining us from the Intro to Programming course, welcome back to the 5th week of the Python session included in our Tech Bytes program. Hopefully you guys had a great long weekend, and the long weekend, and now the other weekend is approaching as well. And hopefully you came prepared to learn some more and have a great time. So without any further ado, let's get to it. All right, in case you already know who I am, guys, my name is Rayan Siddiqui. I am a senior at James B. Cohen High School in the District 211. I love to program. I've made multiple apps for the App Store, have made a dozen different websites, and I'm now really looking towards the content creation side of using my skills to produce some content. And you can find some of my content on my YouTube channel. I host a talk show with some of my friends called Buzzer to Buzzer. You can find that on YouTube as well. And then I like to find some new programs and always expanding my skills. As always, if you want to learn more about me or what I've been up to the past couple of weeks, you can always visit my website at rayansiddiqui.com. All right, let's get down to today's agenda. Firstly, we're just going to start with a quick reminder about our new schedule with this month of September. Just make sure that we are all on the same page. And then we're going to get to our daily fun fact relating the programming language which we are studying, that being the language of Python, to a fun fact which relates to our real world. And then we're going to pick up where we left off last week, that being discussing more about the idea of recursion and the applications which it can have. And then lastly, we're going to finish things off by doing an example with recursion. And yeah, let's get to it. So a quick reminder about the month of September. We will be doing our Intro to Programming course every Monday from 3 to 4 p.m. As you can see, today is clearly September 10th, and we are doing it on a Thursday, which might be a bit confusing. However, just know that the reason why we shifted our Intro to Programming course to this Thursday was because we had that Labor Day weekend on the 7th, this Monday, right? Which is why today is just an exception. Don't think of it too much. Just remember that in the future, all of our Tech Bytes courses will still be happening on Monday. That is, unless another holiday happens. And in case you are wondering about any of the other programs, just remember that our web development course is still happening every Wednesday from 3 to 4 p.m. And you can always tune into Team Plays Trivia. That's a lot of fun. We have a fun time every Friday to kick back and initiate the weekend. That is also at 3 p.m. All right, so let's talk about today's cool Python fun fact of the day. That being that the language of Python is used every single day for data analysis in the apps which we use every day as well. Now let's dissect this one word by word like we usually do. So we know that the language we are studying is Python. And in the past, we've talked about the language which we are studying, like JavaScript and Python. They have endless amounts of applications. I mean, with JavaScript, we've talked about how we can make our own websites and web pages. And with Python, it's a language which is mainly used for that data analysis in the basic terms that it is used to interpret and make calculations, make predictions. And if you are thinking, hey, predictions, and you're thinking about Hack Central, you made a perfect correlation because in our Hack Central program, we talk about using Python to make predictions using machine learning. However, for this Intro to Programming course, the basic idea which I want to get to is how is Python put into play with this idea of data analysis and analyzing large sets of data about people? Well, the reason why Python is mainly used is because we have discussed that Python is a super efficient language with processing large amounts of data. So an example which I would like to talk about is that think about all the social media apps which we have. Say we're talking about the apps such as, we'll take Instagram, right? Well, when you create an Instagram account, just think about all the variables which go into making that account, right? Let's think about it in the programmer sense, right? So you have your username, you have your first and last name, you have your email, you have your birth of date. That's 5 already. You have the hundreds of people who you follow, the tens of people who follow you, and just think about how rapidly and exponentially the variables can increase about the data about your profile. And that can get a lot. Just think about how many friends you have who have these social media apps. That multiplied by billions of people across this earth, that's a ton of data. And mainly companies like Instagram and Facebook, who is a parent company, they use the language of Python to process that information. So right when you create an account, they have a Python program, a script like which we write, to interpret and store your data into a database. Now, speaking of database, Python is very useful in being able to create and manage databases. And it goes to show you that we can, every day when we are using our social media apps, a programming language specifically, is always being used. And also, another side example which comes to play with this is the context of recommending items. Now, if you or your parents have ever used the website Amazon to order items, you might even have a Prime delivery service, you might notice that when you purchase something, Amazon usually recommends a similar item. Like when I open the Amazon app, for instance, or the website, it's going to tell me, hey, you should order this item because why? Why is Amazon telling me to order a similar item based on my order history? Well, that's called a recommender or recommending system. And Python actually is a very big part of that system, because using Python and that idea which we talked through in Hack Central of machine learning, Python makes that recommender system very possible. It recognizes patterns of searching through your order history. So say you order a lot of action figures, right? Well, using Python, you're probably going to be notified on the Amazon app or website that, hey, there's this new action figure which you should probably order, or a video game or clothing brand, whatever the case might be. That's why you probably notice that, hey, why am I getting recommended something I just ordered? And another context would also be the idea of YouTube. You might notice that if you're into, say, car videos, watching some mechanic work on cars, something like that, of that sort, you might notice that your recommendation feed, like the home tab, is filled with a lot of car videos. Well, it's because of the language of Python. Now you know that it's just crazy, right? At the end of the day, when we think about that, every single thing, a lot of the technological things which we have nowadays are because of programming languages which we are studying, like Python and JavaScript as well. Just going to show once more the true impact of what we're learning and how far it can extend as well. All right, so let's get to today's lesson, that being that we're going to be continuing on that idea of recursion. Now, last week I briefly introduced the topic and we did a little example, but we didn't have much time to really go in depth, and this week is dedicated to all that. So let's start off by just defining the term recursion and what does it actually do? Well, recursion is the idea that we have a function which calls the same function from inside that function. Wait, I just used the word function a lot of times. Let's look at this visual example. We have this function called recursion. Ignore the syntax of how this is written. This is a different language, but it covers the same concept. So we have this function called recursion. It has a parameter, which is accepting, and it looks like it is holding that parameter as an integer of as an x variable, right? Now, here comes the recursion part. We're calling the function from inside itself. So we're calling the function recursion from inside the function recursion. Now that's pretty cool and might be a bit odd. Why are we doing that? And how does this function not run forever and ever and ever? Why is there not an endless loop occurring? Well, it's because we have this thing called a base case. If you see what I'm highlighting towards the middle, a base case is what essentially allows us to make sure that using recursion, we don't run our function endless amounts of time. So using a base case, we are usually checking if the parameter which we are passing in, if it meets a certain condition using a logic if-else statement, we are checking if that condition is met, then we usually return a value. Now, we've talked about it previously, but just a quick refresher, a return is using the statement return, a value is being returned to our function. So say we are calling our function from somewhere, from it looks like from inside, right here, right? We, whenever this value is, the parameter value is equal to 0, then a return statement is made, and then that value is spit back. Now, if that is confusing at all, don't worry, we'll be doing a more visualized example. But just remember this, using recursion, we are essentially calling a function over and over again, and then the reason why it's not running endlessly is because that function is usually returning or spitting back, like throwing a value back, which is being added or in some type of mathematical operation. All right, so let's talk about what's the practical use of recursion. Like, why are we even learning this? Well, it's because recursion actually allows us to break very large scale problems into smaller ones. Essentially, when we have a really large mathematical problem, we can easily and more efficiently, usually, break it down into a smaller and a more basic problem. And that way, not only are we having a better understanding as the programmer, but it's much more easier to understand what is happening in the program and how it works. And usually, when we use recursion, the amount of code which we have to write is usually much shorter. So using recursion is usually is very preferred because it saves you not only time, it saves companies money, but it also saves time and efficiency, which matter a lot. And as always, guys, as we're going through this, if you have any ideas, any comments, any questions, feel free to chime in the comments, in the chat section, or in the Q&A. Always ready to listen, or just post it on the Google Classroom. We'll always get back to you guys. All right, so let's talk about today's example, which we will be deep diving into understanding the nuts and bolts of, that being a sequence, a mathematical sequence called the Fibonacci sequence. Now, if anybody, do we have any volunteers of anybody who knows maybe what this is? Okay, how about we just talk about what it is then? Basically, the Fibonacci sequence, to put it simply, is a sequence of numbers in which we are taking the sum of the previous two numbers. So I got these two images towards the left and right here. So if we take a look at the left image, 1 plus 1 is, let me get the highlighter tool on. So I just told you guys that the Fibonacci sequence is the sum of the previous two numbers. So 1, there's usually a 0 right here. So 1 plus 0 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. Seeing the pattern? Hopefully you can realize that whenever, say we take an example like 89, 89 is the result of the sum of 34 and 55. And this right picture puts it in a more indented way, a bit nicer visualization purposes, showing us that 1 plus 1 is 2. That same number added to the previous number is 3. That same number added to the previous number is 5. That same number added to the previous number is 8. Just going to show us that this Fibonacci sequence is indeed a sequence of the numbers in which we are taking the sum and then resulting it to get our next number. So how about we code the Fibonacci sequence recursively, and let's get initiated. So I'm going to open up the Python environment where we usually are programming. Remember, it is called Replit. I'll give everybody a quick minute to get on there as well. All right, there you go. This looks like is the example which we were doing last time. So I'm just gonna open up a new script. All right, there we go. All right, So let's start coding this Fibonacci sequence in the language of Python. So firstly, I'm gonna just create a function called, we'll call it get nth Fibonacci. How about that? That's usually a pretty good way. So this function is going to return us the number of however many Fibonacci numbers we want. So then I'm going to create a parameter that's going to call it number. And then remember, we put the colon, enter sign, like such. And now we have to start coding this. So let's think. We want to call our function get nth Fibonacci recursively, meaning over and over again. And in order to do that, we have to call it inside of itself. Now, we talked about that Fibonacci is the sum of the previous two numbers. So to put that into context, that means that if we use the parameter number, so say I'm going to call my function from right here below, outside of the indentations, I want, say, 4 Fibonacci numbers. Well, that means that I'm going to do the sum of the four first numbers, meaning that it's going to be 0 plus 0, so 0 plus 1, and the sum of 0 plus 1 is 1, and the sum of 1 plus 1 is 2. Like such. So if we just saw that we are taking the sum of the previous two numbers, so how do we translate that into code? Well, how about we put the same idea into play? We're gonna call our function and do the sum of the previous two numbers before the number however many numbers we want of the Fibonacci sequence. So we're gonna do number, our parameter, which is being passed in, minus 1, plus the sum of the same function of our number minus 2, like this. And then remember, we have to return the sum of the previous and the one before the previous number. However, right now we have a problem. If I run this, my computer's gonna lag out because this is going to be an endless loop, meaning it's gonna run for infinite time. Well, that's because we don't have something called, remember, the base case. Now, the base case is what allows us to make sure that our program does not run infinite times. So essentially, we have to create some logic statements which make sure that our program does indeed stop and that we get a result. So let's think about it. So I'm going to tell you right now what to code, and then I'm going to explain why we coded what we did in a visualized whiteboard. So what we're going to do is say if the number equals 1, the parameter ever equals 1, return 0. And then we're going to use an else if, so elif, the number equals 2, return 1. Now, to put it simply right now, before we go to the whiteboard, why we are checking for these two base cases is because we know if the number equals 1, the sum of the preceding numbers is going to be 0. However, if we are checking for the number 2, meaning we're checking for the two Fibonacci numbers, then we know the sum will be 1. Now, if I say just run this, how about we do a prompt? We'll do user int. We'll say input. We'll just say ask the user how many Fibonacci's do you want? How many Fibonacci numbers do you want? And then I'm just going to pass in the parameter user int into my function because we want to get the number of Fibonacci numbers the user requested. I'm going to hit run. So I want 4 Fibonacci numbers. 4 should give me the result of, oh, I'm not printing anything, so that will not happen. Oh, right now this is a string, so we have to convert it into an integer. So just like that. And then I'm going to print the number just to show it. There we go, hit run. I want 4 Fibonacci numbers, it returns 2, which is correct because we have 0, 1, 1, 2. How about we do, we'll do 5. So 5 should return me 0, 1, 1, 2, 2 plus 1 is 3. So we should see the number 3. And there we do. How about we do an even larger example? Say we want 10 Fibonacci numbers. Well, that's going to be 0, 1, 1, 2, 5, 7. And okay, how about I go back to the slide? And if we want 10, well, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we should expect the number 34, I believe it is. Yep, it is. All right, so 34. And that is because we are recursively using this function to go back, calling the function from inside the function in order to get the value of what the Fibonacci number is. So now, if you're at all confused, don't worry. I'm going to actually pull up a whiteboard and go through it by hand, just to make sure that we have a good understanding. So let's try this out. There we go. Hopefully you guys can see that. There we go. All right. So let's think about this example in a more basic sense. Say we have our function and we are doing the call get Fibonacci. We'll do the number 4. And we know that 4 should return the value of 2. So when I call this function, right now the code which we have, that is going to call two other functions, meaning this is going to call the function get Fibonacci. It is the same function because we're using recursion. It's going to say get Fibonacci, remember n minus 1, which is 3, plus get the Fibonacci n minus 2, which is 2. Now, if we start simply with the right, we know we have a base case for this. We know that we have a base case when our number equals 2, meaning when we have a number, the parameter being passed in is equal to 2, we are returning the number 1 because the sum of the previous two numbers is 1, 0, 1. So we return the number 1 right here. Hopefully it's making sense. Then we have this function. Now we don't have a base case for a condition checking when our number, the parameter, equals 3. So another function is going to get called here, meaning we're going to call get Fibonacci n minus 1, which is 2. Get Fibonacci again, that n minus 2, which is 1. Now we have base cases for both of these. So I know that our base case for 2 is going to return the number 1. And our base case for 1 is going to return the number 0. Now the sum of 1 plus 0 is 1. And then if we take these numbers back all the way over here, we get 1. Draw an arrow right there, 1 plus 1, which evaluates to 2. There we go. So that shows us that if I show back my screen, that if I hit run and I put I want 4 Fibonacci numbers, we should see the 4th Fibonacci number being 2. And there we go. So how about we do one more example and visualize it out? Say we'll do 5 Fibonacci numbers. It returns 3. So let's see how that works. Let me go back to the whiteboard. All right, you can see that. There we go. So we're going to do get the 5th Fibonacci number. So same sequence. This is going to call the function get Fibonacci n minus 1, which is 4, and then n minus 2, which is 3. Now, none of these are base cases, so we got to run these, do recursive again, and call the function again. So this is going to call n minus 1, which is 3, and then n minus 2, which is 2. This, on the other hand, is going to call n minus 1, which is 2, and then n minus 2, which is 1. Let's start off with the left. We know that 3 is not a base case, so we got to call another function again. So get Fibonacci n minus 1, which is 2, n minus 2, which is 1. And then get 2 is a base case because 2 is a condition we're checking for, which returns the number 1. Now right here, both of these are base cases. We know 2 returns the number 1 as well, and 1 returns the number 0. So the sum of 1 plus 0, oh, you can see that, 1 plus 0 is 1. So we know that this get 3 right here is equal to 1. And this returns 1 as well. So this statement combined equals 1 plus 1, which is 2. And then we have this right side. We know that both of these get 2 and get 1 are both base cases because we have conditions checking for them. Get 2 returns the number 1, and get 1 returns the number 0. 0 plus 1 is indeed 1, which this 1 goes back up here, which gets us 1 plus 2 equals 3. And if we head on over back to our script, we do see that if we want 5 Fibonacci numbers, we get that the sum of the first 5 Fibonacci numbers is indeed 3. All right, and how about we finish off with one last example, that being the example which we were talking about last week. I just want to make sure that we are doing all good. Last week we were doing an example about, oops, I lost my, that's fine. All right, so last week we were doing an example about using factorial. Remember, factorial is the idea, say I have, so say I have 4 factorial, that means we're doing 4 times 3 times 2 times 1, which in this case a value is to 24. And using recursion, we can do that once again. So I got these print statements right here. We're using recursion in the sense that our base case in this scenario is 1. So if the parameter which we are passing in is ever equal to the number 1, we are returning the value of 1. And then if not, we are going to call our function again by calling the multiplication operation between our number minus the number before it. So if I do factorial of, we'll do 4, we should see the number 24 being printed out. And there we go. Factorial is indeed 24. So how about we take a look at how the factorial math works? All right, so say we want to do that same thing we did, same operation we did with our script. We want to do the factorial. I'll call it still get factorial of the number 4. So remember, we know that this 4 factorial equals 24 on the side. So let's run it. We know that 4 is not a base case, so it's going to call another function from inside itself. So it's going to call get factorial 4 times get factorial n minus 1, which is 3. Now we know that 3 is not a base case, so it's going to call it again. We're going to get factorial, calling 3, 3 times get factorial n minus 1, which is 2. Now 2 is not a base case, so we call it again. Get factorial of 2 times get factorial of 1. And finally, we have gotten a base case. We know that 1 results to the number 1. 2 times 1 is 2. So this whole thing equals 2. 2 times 3 is 6. This whole thing equals 6. And then we know that 6 times, oh, that is sloppy. 6 times 4 does equal 24. And we got that solution recursively. That's pretty cool. All right, so if you guys have any questions at all, this is a pretty advanced topic which we are learning, and consideringly so because we have been doing so much awesome projects, and I just thought that this week we will take a little bit of time out to learn about this topic of recursion because it is something which you should be aware about. It is a method which we can use to break down our problems into simpler problems, and it is a much more efficient method which we can use in many cases as well. So hopefully you saw it interesting as well to see how we can use our programming skills and combine it with some math. So if you ever tell your math teacher that, hey, I can use Python to make an impact and do some math with it, that's pretty cool. And this week we learned how to do that math with factorial and the Fibonacci sequence. All right, guys, then our next week goal is to start a new project, and then we're going to start by learning about a new terminology, that being classes. And don't worry, it is not meaning classes which we have at school. They are a bit more fun in our case, right? We like computer programming. And yeah, hopefully you guys had a great time. Hopefully you enjoyed the fun fact of the day. And as always, guys, take care. And I'll catch you guys in the next one. See you guys.